Assalamualaikum warahmatullahi wabarakatuh and a very good day to Dr. Wahida. This is our video for assignment 2. So here is our team members that consists of 4 people. Introduction of cryptology. What is cryptology? Cryptology is the mathematics such as number theory and the application of formulas and algorithms that includes the study and practice of both cryptography and cryptanalysis. And what is cryptography and cryptanalysis? Cryptography includes all the legit ways of protecting and revealing the data, which means the only person with having the corresponding keys can access the data. But cryptanalysis includes all the ways to break the protection even without having the keys. Cryptology was once the domain of the government, especially for military and diplomatic personnel, but it is more and more becoming a mathematical discipline as mathematics provides the theoretical justification behind the sense of a particular encryption system. Application of cryptology in real life. First, encryption or decryption in email. Email encryption is a method of securing the content of emails from anyone outside of the email conversation looking to obtain a participant's information. Only with private email key can emails be unlocked and decrypted back into the original message. Next, authentication or digital signature. Let me give the situation. If you receive a message from me that I have encrypted with my private key, and you are able to decrypt it using my public key, you should feel reasonably certain that the message came from me. If I think it necessary to keep the message secret, I may encrypt the message with my private key and then with your public key. That way only you can read the message and you will know that the message came from me. Next is electronic money, also called electronic cash or digital cash. It includes transactions carried out electronically with a net transfer of funds from one party to another. Encryption is used in electronic money schemes to protect conventional transaction data like account numbers and transaction amounts. Digital signature can replace handwritten signatures or a credit authorization, and public key encryption can provide confidentiality. And last, the application of cryptology in real life is encryption in WhatsApp. WhatsApp uses the Signal protocol for encryption, which is a combination of asymmetric and symmetric key cryptography algorithm. The data which is encrypted using the public key of a user can only be decrypted using the private key of that user and vice versa.
Caesar cipher was a simple substitution cipher, but it had a memorable key. For the Caesar cipher, letters were replaced by letters standing 3 places further down the alphabet. Here is the key for the Caesar cipher. The key can be memorized because there is a pattern of it. The ciphertext alphabet is just a plain text alphabet shift to the right 3 places. Sender and receiver just need to remember the shift. Another shift also can be used. The cipher are not usually called Caesar cipher. For each of these cipher, the method of encryption is the Caesar cipher, which is a special case of the simple substitution cipher, and the key is the shift. Knowing the key, the sender and receiver can create a plain text or ciphertext correspondence as needed. There is no need to keep written copy of the plain text or ciphertext correspondence. Therefore, the security is less of an issue than is the more general simple substitution cipher. Over the year, the cryptographer have created a disk or slide device to show the plain or ciphertext correspondence for used when encrypting and decrypting. On the top, we can see the Alberti disk. The disk that is shown has the letter in the cell in the usually order. Sender and receiver must agree which circle correspond to plain text and which circle correspond to the ciphertext. The disk that is pictured has ciphertext on the small circle and plain text on the large circle. The disk has been set to the scissors original cipher, which is a shift of 3.
Okay, next we are going to move to scissor cipher example. First, we are going to do the encryption. Okay, let's take example for the phrase, the file is under her bed, in a big case with shift of 12 or rotation 12. There are 4 steps for encryption. So firstly is we create the 5-letter block. This step is optional. Some people prefer to let the word as it is, like the file is under her bed, like that. Some want to make it harder to decrypt by making it a 4 or 5-letter block. Okay, second step is to put the position of the alphabet by using numbers starting from A equal to 0, B equal to 1 until Z equal to 25. As you can see in the table beside this slide, I have put all the position for the plain text or the alphabet, and the position is consecutive. Step 3 is to perform addition by 12 onto each number under modulo 26. We add by 12 because we use the shift of 12, and modulo 26 because we only have 26 alphabet. So the question should be alpha plus 12 equal to beta mod 26. Alpha is the plain text while beta is the position of the ciphertext. Okay, you can see at the table besides, I have calculated every position for the ciphertext. So as you can see, the plain text A have initial position of 0, but after the shift of 12 it has position 12, which actually belong to letter M. So letter M is the ciphertext of the plain text A. So we just have to write down every letters corresponding to it. So step 4, which is the last step, is using the new position, the position of the ciphertext, we rewrite the phrase with the corresponding letters, which is the ciphertext. So this is the encrypted code. Okay. Next, we're going to move to decryption. Decryption means you crack the secret code to get the actual message. To decrypt the ciphertext, we have to know the shift used for the code. There are various ways to find the shift, like guessing or trying to do from shift 1, shift 2 and so on until you find the actual shift. But for this example, we are going to assume that we know the shift. So we are going to decrypt this code Xenoyi GYKY with rotation 6. So firstly, the first step is to find the position of the plain text. The step is actually the same as step 1 until 3 from the encryption, but we use addition operation of 6 instead of 12 because we have the shift of 6. So we can see the plain text A have a ciphertext of G, plain text B have ciphertext H, and so on. Okay, step 2 is to decrypt the message. If we want to encrypt, we convert plain text into ciphertext, but for decryption, we convert ciphertext into plain text. Easy, right? So we found out that letter Z ciphertext have a plain text of T, N is H, and so on, and we get this description message. So step 3 is to rewrite the message so that we can read it properly. So the message from the code is, this case is very urgent. I guess that's all from me.
Next is the affine cipher. It's a type of monoalphabetic substitution cipher where each of the letter in an alphabet is mapped to its numeric equivalent. Encrypt using a simple mathematical function and convert back to a letter. First is encryption. Encryption is a step in the encryption process to transform each of the letter in the plain text alphabet to the corresponding integer in the range of 0 to m-1. With this done, encryption process for each letter is given by EX equal to AX plus B multiple with modulo M, where A and B are key for the cipher. This means that we multiply our integer value for the plain text letter by A and then add B to the result. Finally, we take this modulus M, that is, we take the remainder when the solution is divided by M, or we take away the length of a alphabet into a, we get a number less than this length. Next is decryption. In deciphering the ciphertext, we must perform the opposite function on the ciphertext to retrieve the plain text. Once again, the first step is to convert each of the ciphertext letter into their integer values. We must now perform the following calculation on each integer, where is dx equal to c x minus b modulus m, where c is the modular multiplicative inverse of a, that is a x c equal to 1 modulus m, where the c is the number such that when you multiply a by it and keep taking away the length of the alphabet, you will get to 1. This can be used to encrypt or decrypt each individual letter of the plain text.
Example of a fine cipher. First, encrypt. Let's encrypt the ciphertext "Keep your distance and wear a mask" using the key A equal to 5 and B equal to 8. Firstly, we must find the integer value of each of the letters in the plain text alphabet of 26 letters in the case by using table of plain text alphabet and value. With the integer values of plain text letter found, the next step is to perform the calculation on those values. The calculation needed is 5x plus 8. Finally, we must ensure that all our answers are calculated mode 26 and convert integers back to ciphertext letters. All the information are in the table shown. Thus, the ciphertext produced is GBBF YAEP XWUZ IVSB IVXO BIPI QIUG. The example of a fine cipher for decrypt. Let's decrypt the ciphertext GBBF YAEP KWUZ IVSB IVXO BIPI QIUG by using a key of A equal to 5 and B equal to 8. In deciphering the ciphertext, we must perform the inverse function to retrieve the plain text. We must calculate on each integer by using dx equal to A inverse x minus b mod m. We find the inverse of A, which is 21 in this case. Now, we calculate the inverse on the integer values of ciphertext by using 21y minus 8. Once again, we must take this answers modulo 26 and convert the integers back to plain text letter. For negative value integers, we need to plus the value with m. All the information are shown in the table. Retrieve our plain text of "Keep your distance and wear a mask."